The first paper we were asked to read is Anders from 1982. The experiment had to do with the comparison of the tail length in male long-tailed widow birds and the female's choice of their mate. In this experiment, there were 9 groups. Each group had 4 individuals with similar tail lengths and territories within the group. One male had its tail cut down to 14 centimeters in that group, which was the shortened tail feather. The elongated one had the tail feathers cut from the shortened one added to it to give it the elongated look. There were 2 control groups. One of them had its tail feathers cut halfway and glued back on to eliminate the bias of tail manipulation, and the other control was left alone. Flight displays and territorial disputes were observed before and after the treatment to determine if they had changed at all, and the mating success was estimated by the number of active nests on the territory. The results were the males with shortened tails had lowest success, males with elongated tails had the highest success. The reduced tail individuals increased their rate of display, but this did not increase their success with the females. In conclusion, the length of the tail had an effect on the selection of the mate, quite possibly because this could be a reflection of their phenotypic or genotypic quality, or it could be because of the easier detection by the females. The second paper that was read is Moeller. The experiment consisted of 8 sites with 1 to 17 breeding pairs of swallows. The swallows were captured at night. 44 of them were banded, put into 4 groups. The first group had 20 millimeters cut off their tail with a reduced length by 19.8%. The second group had 20 millimeters added to them with a 16.7% increase. The first one was 85 millimeters, second one was 127 millimeters. Group 3 had their tails cut and glued back on to eliminate the manipulation factor. And group 4, they were left alone. Both group 3 and 4 had roughly 106 millimeter tail length. The success was measured by the time of arrival to the time of pair bonding. The results were the males with the shortened tails took 4 times as long to be selected for mating as the elongated males did. The shortened tails were rejected more by the females. Their display rate did not affect it. Clutch size or reproductive success was 2 times of the shortened males for the elongated males. And the extra pair copulation rates were higher within the elongated tail males. The important takeaway was that the female selection of males with elongated tails could be reflection of male genotypic or phenotypic qualities, or the possibility of having a healthier lifestyle. In conclusion, the tails in the swallows have quite possibly evolved by choice of the female, selection of the male. The third paper that we were asked to read is Nowicki 2002. The experiment compared the brain development and song development in swamp sparrows. Nestlings were gone out and collected. One group was fed until they were satisfied. The other group was fed in 70% of what was fed to the first group. They were put in isolation chambers where songs were played, and they were then recorded during their sub-song stage to determine what songs they had learned. The crystallization stage had been evaluated to determine their repertoire, and the results came out that the experimental group produced much fewer copies of the model than the control group had. And there was no difference in song complexity, which is possibly due to the swamp sparrow having a normally small repertoire. The brain volumes were lower in the nutritionally stressed birds as well. And the takeaway is, even in brief nutritional stress, it can cause long-term brain development effects. It can cause the outcome of the song learning.